Okay, so with this one, this symbol at the start here means that for all y, there exists an x such that this is true. So if we look at this one, like that's y equals the absolute value of x. So for all of y, there has to be an x where the absolute value of x will equal y. Now, if y was negative, then this can't be true, because there does not exist a y for this to happen. Okay, so it's not true for all y. It's true for positive y, and it would be true for 0, where y is 0. You could get an x, that's where x equals 0. But like say you have y equals 4, then that means that you could do the absolute value of 4 equals 4. But you can't get there does not exist an x where the absolute value, say, equals minus 4, where y is minus 4. That's untrue. So that means that the first statement can't be true. The second one, y is greater than the absolute value of x. So for all y, so let's say if y was positive, like you go 10 is greater, there is a 10, there's a value that exists. But if y was negative, so you have minus 10, is there a value of x for which this exists? No, there's none. Oh, so that it's less than minus 10, never. Like it wouldn't matter if you put 8 in, even if you put 2 in. 2 is less than if it was 10, but not than minus 10. So it's not A, and it's not B. Now, if we look at D, it definitely can't be D, because if you put a y in there, if you put y is positive, then you can't get an x value. So your absolute value of 3 equals, you can't get an x value that's going to give you a negative answer. But if y was negative, then you could get x values for that, because it would be a negative and a negative. And that means that you could put in, say, the value of 3, or you could go negative, negative 2. That exists, that'll give you a positive 2, the absolute value of 2 is 2. And the absolute value of minus 2. So there's x's that exist will give a positive answer. Okay, so that just leaves us with the last option. So let's just have a look at that. This is C. And this will be your solution by process of elimination at the moment. But for all, is there a y that is always, can we get y's that are less than the absolute value of x? Now, considering the absolute value of x is a positive, if y was a positive, say 2, can you find a value of x so that would be greater than that? Yep. Even minus 3, yep, that would be greater. If y was equal to a negative, say minus 6, can I find a value of x that is greater than that? Yeah, minus 1. We could put 4. So that does work. It does exist for negative. So therefore, the answer is C.